Hello everyone and welcome to final module of Lesson 8. In the previous module, we covered the topic of estimating activity durations. Today, we're going to discuss the developing a project schedule. A well-crafted schedule is vital for managing a project effectively. It helps determine the project timeline, serves as a key communication tool, and identifies critical activities and milestones. Let's explore each of these points in detail. The first and foremost importance of developing a project schedule is determining the project timeline. Establishing a clear timeline helps in visualizing the entire project from start to finish. Impact: it allows the project team to understand the sequence of activities, estimate the duration of tasks, and set realistic deadlines. Example: for instance, in a software development project, creating a schedule will help map out all phases, from initial planning and design to coding, testing, and final deployment. This ensures that each phase is allocated appropriate time and resources, reducing the risk of delays. Imagine managing a construction project. Without a detailed schedule, tasks like foundation laying, framing, electrical, and plumbing could overlap inefficiently, causing delays and resource conflicts. A well-defined schedule ensures that each task follows a logical order, keeping the project on track. The second point is that a project schedule acts as an essential communication tool. It communicates the timeline, key tasks, and milestones to all stakeholders, ensuring everyone is on the same page. Impact: clear communication through the schedule helps in setting expectations, coordinating efforts, and fostering transparency within the project team and with external stakeholders. Example: in a marketing campaign, the schedule informs the team about deadlines for content creation, design approvals, and campaign launches, ensuring synchronized efforts and timely delivery. Consider a large event planning project. The schedule would outline deadlines for booking venues, sending invitations, arranging catering, and setting up equipment. Sharing this schedule with all team members ensures that each person knows their responsibilities and deadlines, preventing misunderstandings and last-minute rushes. The third importance of developing a project schedule is to identify critical activities and milestones. Highlighting these critical points ensures that key tasks are completed on time, which is crucial for the overall project success. Impact: identifying critical activities helps prioritize resources and attention to tasks that have the most significant impact on the project timeline. Milestones serve as checkpoints to assess progress and make necessary adjustments. Example: in a product development project, critical activities might include completing the prototype design, initial testing phases, and securing regulatory approvals. Milestones such as prototype completed and initial testing phase started help in tracking progress and maintaining momentum. Picture a film production project. Key milestones like completing the script, casting, finishing principal photography, and post-production editing are crucial for timely release. Identifying these milestones in the schedule helps the team focus on these significant phases, ensuring the project stays on course. In conclusion, developing a project schedule is crucial for determining the project timeline, serving as an effective communication tool, and identifying critical activities and milestones. A well-structured schedule not only provides a roadmap for the project team but also ensures that all stakeholders are aligned and focused on the project's goals. In this block, we will delve into the steps involved in developing a project schedule. By following these steps, you can ensure that your project remains on track and that all activities are planned efficiently. Let's begin with determining activity dependencies. The first step in developing the project schedule is determining the dependencies between activities. Finish to start: FS the most common dependency where one activity must finish before the next one starts. Example: the foundation of a building must be completed, finish, before construction of the walls can begin, start. Start to start: SS2 activities can start simultaneously but are independent in their completion. Example: you can start painting a wall, start, as soon as the wall construction starts, start. Finish to finish: FF2 activities must finish at the same time. Example: testing and bug fixing in software development often need to finish together. Start to finish: SF the start of one activity determines the finish of another. Example, the start of new software deployment determines the end of the old system operation. Imagine planning a wedding. The ceremony, FS, must finish before the reception begins. Simultaneously, decoration setup, SS, can start at the same time as the catering preparation. Both decoration and catering setup need to finish before the guests arrive, FF. The start of the DJ performance determines when the live band should stop playing, SF. The next step is determining how long each activity will take. Involve team members, engage the team to gather realistic estimates. Example, ask the construction team how long each phase of building a house will take. Techniques, use techniques such as expert judgment, analogous estimating, and parametric estimating. Example, use historical data to estimate the duration of similar past activities. In a software project, involve developers to estimate coding tasks, testers for testing phases, and use past project data to predict durations. Combining these estimates gives a realistic timeline for the software development lifecycle. The third step is to develop a project network diagram. Sequence of activities and dependencies, create a visual representation of activities and their dependencies. Example, use nodes to represent activities and arrows to indicate dependencies. Identify the critical path, determine the longest path of dependent activities. Example, identify which tasks directly affect the project completion date. Techniques, use precedence diagramming method, PDM, or arrow diagramming method, ADM. Example, draw a PDM diagram to map out the project schedule visually. For a product launch, develop a network diagram showing activities such as product design, testing, marketing, and final launch. This helps visualize the sequence and dependencies, identifying the critical path and ensuring key tasks are prioritized. The fourth step is performing schedule calculations. Early start, ES, and early finish, EF, calculate the earliest times activities can start and finish based on dependencies. Example, if task A starts on day 1 and takes 3 days, it finishes on day 3, and task B can start on day 4. Late start, LS, and late finish, LF, calculate the latest times activities can start and finish without delaying the project. Example, if the project deadline is day 10, and task B takes 3 days, the latest it can start is day 7. Based on dependencies and durations, use the calculated early and late times to identify flexibility and critical activities. Example, tasks with no slack are critical and need close monitoring. In a marketing campaign, if designing materials, task A takes 5 days starting from day 1, it will finish on day 5, EF. The review process, task B, can then start on day 6, ES. If the final launch is on day 15, calculate the LS and LF for tasks to ensure timely completion. Step 5 is identifying the critical path is crucial for determining the overall project duration. Determine overall project duration. The critical path shows the total time required to complete the project. Example, if the critical path has activities summing up to 20 days, that is the minimum time to complete the project. Focus on managing activities with no flexibility. Critical activities have zero slack and need focused management. Example, monitor tasks on the critical path closely to avoid delays. For a film production, tasks such as script writing, filming, and editing may form the critical path. If any of these tasks are delayed, the entire project is delayed. Identifying this path helps prioritize and manage these tasks effectively. The final step is creating the project schedule based on previous calculations and critical path analysis. Based on schedule calculations and critical path analysis, compile all information to form a comprehensive schedule. Example, include all activities, durations, dependencies, and start-finish dates. Present in formats such as Gantt charts or project timelines, use visual tools to present the schedule. Example, Gantt charts visually display activities against time, showing dependencies and progress. Include activity names, durations, start-finish dates, dependencies, and milestones. Ensure the schedule is detailed and clear. Example, a project timeline showing key milestones like project kickoff, critical reviews, and final delivery. In an event planning project, create a Gantt chart showing tasks like venue booking, invitations, catering, and setup. Include start and finish dates, task durations, dependencies, and key milestones like venue booked and invitation sent. In conclusion, developing a project schedule involves determining activity dependencies, estimating durations, creating network diagrams, performing schedule calculations, identifying the critical path, and compiling the final schedule. By following these steps, you can ensure efficient project management and timely completion. In this final block, we will explore the vital aspects of schedule management and control. Effective schedule management ensures that projects stay on track, and any deviations are promptly addressed. This involves continuous monitoring, utilizing various techniques, addressing deviations, and maintaining clear communication. Let's dive into each of these elements. The first key aspect of schedule management is continuous monitoring. Purpose: regularly tracking the progress of project activities ensures that everything is proceeding as planned. Impact: helps identify any potential delays or issues early, allowing for timely corrective actions. Example, in a software development project, weekly progress reviews help ensure that coding and testing phases are on schedule. Imagine managing a construction project. By conducting daily site inspections and weekly progress meetings, you can monitor the completion of tasks like foundation work, framing, and roofing. This continuous monitoring helps ensure that each phase is completed on time and any issues are promptly addressed. The second aspect is utilizing various techniques for effective schedule management. Gantt charts provide a visual representation of the project schedule, showing task durations and dependencies. Example, a Gantt chart for a marketing campaign outlines tasks such as content creation, design, and distribution, displaying their start and finish dates. Critical path method, CPM, identifies the longest sequence of dependent tasks, highlighting the critical path that determines the project duration. Example, in a product development project, CPM helps identify tasks like design, prototyping, and testing that are critical for timely completion. Earned value management, EVM, combines scope, schedule, and cost data to assess project performance and progress. Example, EVM helps track project performance against the planned schedule and budget, identifying any variances early. For a large-scale event, use a Gantt chart to map out tasks such as booking venues, sending invitations, and arranging catering. Apply CPM to identify the critical tasks that must be completed on time. Use EVM to track the budget and schedule, ensuring that the project stays within its planned scope and cost. The third aspect involves addressing deviations from the planned schedule. Identify issues early, use continuous monitoring to detect delays or problems as soon as they arise. Example, in a construction project, early detection of a delay in material delivery can prompt immediate action to find alternatives and avoid further delays. Implement corrective actions, develop and execute plans to bring the project back on track. Example, if a software development project falls behind schedule, reallocate resources or extend working hours to meet deadlines. Adjust the schedule, update the project schedule to reflect changes and communicate these updates to stakeholders. Example, in a marketing campaign, if content creation takes longer than expected, adjust the schedule to extend the design phase without affecting the final launch date. Imagine an IT infrastructure upgrade project. If a key hardware shipment is delayed, identify the issue early and expedite an alternative supplier. Adjust the project schedule to accommodate the new delivery timeline and communicate this change to the project team and stakeholders. The final aspect is maintaining clear and consistent communication throughout the project. Purpose: keep all stakeholders informed about the project's progress, changes, and any issues that arise. Impact: ensures transparency, builds trust, and facilitates collaboration among team members and stakeholders. Example, in a product launch, regular updates to the marketing team, product development team, and senior management help ensure alignment and timely decision-making. Methods: use various communication tools such as status reports, meetings, and project management software. Example, weekly status reports and bi-weekly meetings can keep everyone updated on the project's progress and any changes to the schedule. In a construction project, use daily briefings and weekly progress reports to communicate with the project team, subcontractors, and clients. This helps ensure that everyone is aware of the project status, any changes, and the next steps. In conclusion, effective schedule management and control involve continuous monitoring, utilizing appropriate techniques, addressing deviations promptly, and maintaining clear communication. By implementing these practices, you can ensure that your project stays on track and achieves its objectives on time. Developing a project schedule involves several critical steps, including determining activity dependencies, estimating durations, creating a project network diagram, and identifying the critical path. Effective schedule management and control are essential for monitoring progress, addressing deviations, and ensuring clear communication with stakeholders. Utilizing tools such as Gantt charts, the critical path method, CPM, and earned value management, EVM, can help manage and adjust the schedule to keep the project on track. Now it's time to summarize the information we've covered so far. To check how well you have understood the material, please follow the link below the video and take a short quiz to help you consolidate the knowledge you have gained in Lesson 8. I appreciate your attention and look forward to your continued participation in the next lessons. Like and subscribe to the channel.